Good evening, you Precal Bearcats. We are in Polynomial Functions of Higher Degree, Section 2.2, and I want to give you just some few things that you're going to learn to do. One, you're going to learn to use transformations to sketch the graphs of polynomials. So you're going to use transformations, which we've talked about already. You're going to use the leading coefficient test to determine the end behavior of your polynomials. We're going to discuss that today. You're going to find zeros of polynomials to help you sketch. That's very important. We've been doing that. All those methods that we've been using to find zeros, which were completing the square, factoring, quadratic formula, will all help you to find your zeros. And finally, we might learn about the intermediate value theorem to help us locate zeros for those that are not at nice, pretty whole numbers. All right, a couple of things about polynomial functions that you need to know. I think it's easier sometimes to know what they're not. A couple of things about polynomials. Polynomials have smooth curves. They are smooth curves. They are no sharp turns, so this is not a polynomial. They also are always continuous. They are continuous. You never have to pick up your pencil. You just go right along the smooth curves, and they are continuous. So this is also not a polynomial. So I just wanted to give you an idea of what a polynomial is and what it is not. Okay, next I want to talk to you a little bit about the simplest form of polynomials, which are monomials. We have two examples here, right here and right here. And I just want you to know a monomial, of course, is a polynomial with the a power greater than 1. With a power greater than 1. So here we have a quadratic, an x squared, and we have x to the 4th. If they are monomials and there's nothing else going on in your problem, then they're going to keep the shape of the original lower degree polynomial. So an x to the 4th or 4th degree monomial is going to be very similar in shape to a 2nd degree monomial, and you can see that demonstrated here. It just flattens out a little bit more as it approaches the x-axis. The same over here, you have a 3rd degree polynomial and a 5th degree monomial, and again it's very similar to the original, it just flattens out a little more at the x-axis. That's really important that you recognize this, because you'll find these shapes within other higher degree polynomials. Notice something important. If it is a even polynomial, if it is even, the degree is even, like a 2nd degree or a 4th degree, it touches at the x-axis and then goes back up, or it would, coming from the bottom, it would touch and go back down. Notice that if it's an odd monomial, if the degree is odd, then it crosses over the x-axis. So those are just some observations that we're learning about right now. A couple of things that are important, just so you know, often the monomial polynomial is referred to as the power function. The power function. So that's kind of a word that you might hear, a power function. It's given in this form. The form is, of course, f of x equals y to the nth power. If n is even, the graph is symmetric with the y-axis, and if it is odd, it is symmetric with the origin. And that's just some other information about our polynomials, and the simplest form of which is a monomial. All right, next let's talk about the leading coefficient test. Probably one of the most important things you're going to know about learning about the behavior of your graphs. We've got some examples over here we're going to look at in a minute, but before we do that, I want to talk a little bit about our leading coefficient test. Our leading coefficient test has to do with the lead, or the term in your polynomial with the greatest degree. The term in the greatest degree. When the polynomial, the degree is odd, the n value is odd. Take a look at that right there. The n value, the power is odd. Then your graph will be opposite behavior on the extreme ends of your graph. In other words, this is an odd monomial, and on one extreme of your graph you're moving upward, and on the other extreme of your graph you're moving downward. Okay, so they're going to go at opposite directions at the extreme ends of your graph. That's important. So when it is odd, it will be opposite at the ends of the graph. And we've got some notation we're going to talk about in just a minute. When they're even, they're going to be the same at the ends of your graph. So notice over here, these are even That's an even monomial, and they both ends of the graph, they both go up. It could also be negative and they could both go down, but they will be the same. So when it is even, you have the same at the ends of the graph. The other thing about the leading coefficient is if the leading coefficient is positive, okay, I'm going to add this on here. If it is positive, then the right side turns up. If it is negative, then the right side of the graph turns down. Okay, let's look at these examples, and that's going to help us a little bit. We want to make sure that these are all in standard form. It does look like they all are in the right order. The highest degree is the first term. So we're going to first look just at, oops, I kind of messed that up. We're going to first look at just the leading coefficient. Maybe we'll highlight that. It'll make it a little bit easier. So just the leading coefficient. So let's take a look at that for a second. All right, so we have x cubed. X cubed. All right, it's cubed, so it's going to have opposite behavior. If I were just to sketch a little graph, let's talk about what would happen. It has opposite behavior. On the right side of the graph, it would go up because it's positive. And since it has opposite behavior, on the left side, it would turn downward. Let's talk a little bit about notation. In other words, on the right side, as our x values approach infinity, as they get really, 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 really big, our y values, or our f of x, is going to approach positive infinity. So we would write that as x approaches positive infinity. Our f of x also approaches positive infinity. Let's look at the left side. As we move toward negative infinity with our x values, so as x approaches negative infinity, our graph in this case is moving downward, so our y values are approaching negative infinity. So our f of x is approaching negative infinity. All right, so there's just some notation. I'm going to erase this so I have a little bit more room to write, and then you might want to pause it for just a minute so that you can see what I wrote here and really understand it before we go on. And we'll spot check a few of these. We won't do them all, but there'll be a little few extra for you to practice. I may give you a few of those when you get to class tomorrow to see how well you did. Actually, I think I've changed my mind. I think what I'm going to do is I'm going to do 2 more of these, and then the ones I don't do, I want you to go through and write down the leading coefficient and write the end behavior, and you'll just turn that in to me when you walk in the door tomorrow. Don't tell anybody, so if they didn't watch the video, they're not going to know that, and that's just a way for me to check. So make sure your name and your class period's on it, and I'll tell you how to label it in just a second. Okay, let's take a look now at this one right here. We have odd behavior. We have an odd degree, so it's going to be opposite at each end. Let's talk about what that looks like graphically. They're going to be opposite each end, and it's negative. So it's negative, begins with the negative. We know it's going to go down on the right, and because it's opposite on each end, it would have to go up on the left. Let's talk about our notation. Again, as x approaches positive infinity, our y value would be approaching negative infinity. On this side, as our x value approaches positive infinity, our y value is approaching positive infinity. So we could write that as our x value approaches positive infinity, our f of x on the right side is approaching negative infinity. And again, on the left, as x approaches negative infinity, our f of x is approaching positive infinity. Hopefully that makes sense. If it doesn't, pause, take a look at it. I'm going to do one more, and then I'm going to leave you several to do to turn into me when you come in tomorrow. All right, and let's go down here and pick up an even one. We'll pick up this one right here. The 2 in the front doesn't matter. It's just whether it's positive or negative. So just so you know that, and those other ones that are left. All right, so this one is x to the 4th. It's even, so we know it's going to be the same on both sides. All things are even, the same. That kind of makes sense. And it's positive, so it's going to go up on the right. So we know it's going to go up on the right, and because it's even, it will also go up on the left. So let's take a look at this. As x values approach positive infinity, our y values are approaching positive infinity. As our x values approach negative infinity, our y values are approaching positive infinity. So, regardless if you go to the left or the right, whether your x values are positive or negative, so we could write this one this way. As our x values approach positive or negative infinity, our f of x, our y values are always going to be going up, so our y values are going to approach just positive infinity. And you could write your answer that way. Okay, pause again. Think about that. I'm going to erase all this little section down here, and I'm going to circle the ones I want you to turn in to me tomorrow. I think you'll have like 1, 2, 3, 4 of them on a piece of paper. You're more than welcome just to write the leading coefficient down. I'd like a little sketch of just the arrows on a graph, and then I would really like this kind of notation. You'll turn that in at the beginning of class tomorrow when you walk in the door. So I will probably just empty my basket and have the basket sitting up there for you to turn it in. And I will give you a grade for listening to the video, taking notes, and doing that. All right, so let me go ahead and erase. All right, these are the 4 that you will do. The 4 you will do will be the second one, the third one, or this 4th one, sorry, and then down here, this one, and the last one. Okay, so those 4 that you will do and turn in on a piece of paper tomorrow. So what I want is I want you to put number 1, and you'll write 2x to the 5th, and then just dot, 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 because you know it continues. I want a little graph with arrows up and down, either the same or opposite, and then I want your notation as x approaches, and then as f of x approaches. Okay? All right, I want for those 4 things you'll turn in for a grade tomorrow. All right, let's move on. All right, let's take a look at this example, and let's use some of the information that we just talked about, which is the end behavior, as well as finding the zeros, which we've been doing for a while now. Let's look at finding zeros. Most of these you'll be able to use factoring at some point to help you find your zeros, which remember on a graph are your x-intercepts. So the first thing I'm going to do is I'm going to come over here and I'm just going to sketch just those little arrows again about what's going to happen to my graph at the ends. I know this is a odd degree, so I know it's going to be opposite on each side. On the right side, this side over here, I know that it's positive, so it's got to go up. And since it's got to go up on the right and it's odd or opposite, it's going to go down on the left. So in a minute, my graph should look like that. I'm going to go ahead and sketch. I will try to have graph paper for you tomorrow so that you can actually get good, pretty graphs. All right, so here we go. So we already know this information. So on my graph and on yours, when you do this, I would make sure that you know that the end behavior looks like that. The next thing we're going to do is we're going to see if we can find some x-intercepts, and then we're going to go from there and see what else information we can find. So it looks like to me that there's a GCF. Always look for GCF. That would be our greatest common factor, and that happens to be an x. Then you would have x squared minus x minus 6. I believe you can factor this, so keep the x. Remember, you're finding zeros, so you've set them equal to 0, and you should be able to factor this. X and x. Multiply to negative 6, add to negative 1. I believe that's going to have to be negative 3 and positive 2. Negative 3 and positive 2. All right, and so our zeros, we have 3 of them. We would have 0. These are your x values. You would have positive 3, and you would have negative 2. And those are your 3 zeros. So let's go ahead, since those are also your x-intercepts, let's go ahead and plot those. So we have a 0 at 0. We have 1 at negative 2, and we have 1 at positive 3. At positive 3. All right, let's see what else we know. We don't know what's happening between 1 and 3. So let's create a little table. and just old-fashioned plug in some numbers to find out what's happening at 1 and 2. That'll give us a little better picture of our graph. Our y-intercept, of course, is when the x values are 0. If I go back up and put all zeros in for the x's, my y-intercept would be at 0, 0. In this case, our y-intercept and our x-intercept are both at 0 at the origin, at 0, 0. All right, so let's go back to our t-table. So we know what happened at 0, we know what happened at 3. Let's see what happens at 1 and at 2. And on the left side, let's see what happens between 0 and -2, which would be at -1. So let's just try to find those points and see what happens. Okay, so if we plug a 1 in for our x values, and we plug all that in and we solve it, we should end up with -6. So we would have an ordered pair at 1, -6. So at 1, we'd be down here at -6. We'll just count 1, 2, 3, 4, 5, 6. It'll be a little easier on some graph paper for you. So there's a point on our graph. If we plug in 2 for our x values, and we calculated, we would be at -8. So that's at 1, and this is at 2, and we'd be down here at -8. All right, we don't know what else, but we know the graph has to come back up on this side. All right, let's see what happens at -1. Sorry, I didn't put my -8 in there. At -1, if we plug in -1 for each of our x values and we calculate our value, we get +4. So it would be at -1, 1, 2, 3, 4. All right, so let's go ahead and draw our graph. I do want you to understand that this lowest point dot we have on our graph does not mean it is the lowest point of the graph. It is not necessarily a relative minimum or maximum. We will work on finding that later on, and primarily in calculus. But right now it is just the lowest point. So we're just going to use that to sketch, but this is not exactly accurate. Just so you know, the end behavior is accurate, and our x-intercepts and y-intercepts are accurate, and we have a few points along the curve, but we do not have every point. So just make sure you understand that. So we're going to come down here, and we're going to go down, and we're trying to make pretty curves. We're going to cross through our thing. We're going to come up and make another curve, and we're going to come back down. And our graph's going to look something like that. Something like that. All right, let's take a look now at the steps necessary once we've done one of these, and then we'll do one more example, and then we'll be done. And this should help you with your classwork tomorrow. Okay, steps to graphing polynomials. These are our basic steps. We're going to learn a little bit more as time goes on, and things will get a little bit more complicated, but for right now, these are our 5 basic steps. The first thing we're going to do is look at the coefficient, our leading coefficient, and that's going to tell us about our end behavior. So what happens to the graph on the right side and the left side? Does it go up and then down? Does it go down and then up? Does it go up and up? Or does it go down and down? Okay, and that leading coefficient will tell us all of that information. Okay, all of that, looking at that one term in your polynomial, will give you that end behavior. All right, second of all, our step 2 will be find the zeros. And right now we'll mostly be factoring. Later on we're going to learn some other methods to find our zeros. But for right now we'll be mainly factoring to find our zeros. Finding zeros are solutions or roots, and when you find those, it's the same as your x-intercepts on your graph, and so you'll plot those. I also suggest you graph as you go. Oops. The third thing you're going to do is you're going to find the y-intercept. And remember, the y-intercept is when x is 0, and then you're going to figure out what the y-intercept is, and you're going to plot that point. The fourth thing you're going to do is you're going to make a t-table. So a table of values for additional points. Okay, so you just make one of those little T-tables to find additional points, and you're going to plot those points. And then finally, you'll sketch your graph. Like I said, it'll be a little more complicated as time goes on, but for now, that's your basic plan, and that's what will help you through your classwork tomorrow. All right, next, or last, I want to do one more example using these steps. All right, so our first step is to look at the leading coefficient, or the leading term. It looks like to me, if I have my graph over here, and I think tomorrow you'll have graphs, I'll get you some graph paper, but if I looked at this, I see that it's an even exponent, and because it's even, I know it will be the same behavior on both sides, and because my first term is positive, I know that my right side will go up, and because it's the same, my left side will also go up. That's the first thing I did, was look at the end behavior. If we were to write that, and I think it's important that you do, our end behavior, the notation would be as x approaches positive or negative infinity. In other words, it doesn't matter if we go off to the right or we're going off to the left. Our y values are both moving upward to positive infinity. Our f of x would be moving to positive infinity. So that's how our behavior would be written. All right, number 2, step 2. Step 2 is to find our 0. So let's look up here, and I believe we have a common factor of 2 and x squared. So we would factor out 2x squared. Inside the parentheses, we would have x squared, and then we would have plus 4. That should be minus, I believe. I'm not sure the problem really was a minus, but I'm going to change that to a minus to demonstrate something. So we're going to use it as a minus. All right, so we're going to say it's minus 8x squared. So it would be, we factored out the 2x squared, and we would have x squared minus 4. And you recognize this is a difference of squares. So now you keep factoring, and you get 2x squared. And then this becomes, so this is one factor. And you can bring these to 2, and this would be x plus 2 and x minus 2. All right, we have fully factored. It's equal to 0. We set each factor equal to 0. This would be our zeros, or our x values would be at 0, negative 2, and positive 2, which are also our x intercepts. So let's plot those points. So we have one at 0. We have one at negative 2. We have one at positive 2. All right, the third thing we're going to do, we found our zeros, is we're going to do our y-intercept. Well, our y-intercept in this case is at the origin. It's also going to be at 0, 0. So we already have that marked on here. The fourth thing we're going to do, and I'm going to try to get myself a little more room. The fourth thing we're going to do is find, pick a few more points. So I'm going to come over here. I'm running out a little bit of space, and I'm going to make myself a T-table. And so I'm going to pick values. Since I don't know what happened at 1 or negative 1, those are the values I'm going to choose right now. Sometimes I might choose a value outside of the negative 2 and the positive 2, but let's just see what this gets us. So if I plot 1, then I would plug a 1 in up here for this x, and I would have 1 to the 4th power is 1 times 2 would be 2. I'm just going to do that off to the side here. And I'd plug a 1 in for here. 1 squared is 1, and 1 times 8 is 8, so I'd have 2 minus 8, which would give me negative 6, so negative 6. So I have the ordered pair 1, negative 6. 1, 2, 3, 4, 5, 6. So I have that ordered pair. And then I'm going to plug in negative 1. If I plug in negative 1 and I raise it to the 4th power, it's positive 1, so I'm going to get 2 again. If I plug in negative 1 in square, it's going to be positive 1 and negative 8 again. And that's also negative 6. It's going to be a very symmetrical graph. All right, I'm going to erase this little bit right out here to the side. If you need to pause, go ahead and pause and write it down for yourself. I'm going to erase this just to give my graph a better picture here. And so I'd be at negative 1, negative 6. And my graph would look something like this. It goes up on the right, we know that. It comes through these points. They're my smooth curves. You're going to come up and curve, and you're going to come down and curve, and you're going to go up and curve. And you have arrows on this end moving upward forever. I didn't make a very pretty curve right there. That should make a lot smoother curve in there that I made. Okay. Again, these may or may not be, this may or may not be the lowest point of the graph. The graph could actually scoop down a little bit further and come back up through those points. We don't really know, but for right now, for curve sketching, we're just going to use those base points. All right, hopefully that helps. That's what our classwork will be over tomorrow. Don't forget to turn in your little sheet of paper to the basket when you come in tomorrow. I'm not going to ask. I'm simply going to pick them up at the end of the class period or at the beginning of the class period. As soon as class starts, I'm going to pick them up and I'll give you a grade for them. So it's pretty much you either do it and understood it or you didn't do it because you didn't prepare for class, and that's not going to be very good. So hopefully that you did it, and I will see you tomorrow. Go Bearcats!